Discrete variables must be whole numbers. Number of students, desks, number of classes. Continuous can include decimals. Example, how many ounces of Dr. Pepper that is in a can? The volume of gas in a car. Time. A probability distribution lists the possible outcomes and their probability. Probability must be between 0 and 1. The lines underneath the less thans mean or equal to, and that means include. Can't be negative, can't be more than 1. It can be 0, and it can be 1. The total when you add must equal 1. This is because 1 is the decimal form of 100%. Probabilities or percents change to a decimal. If you're given a probability distribution, P of X means the probability that X happens. So if it says P of 0, that would be 0.01. P of 3 or more, you would add the probability of 3 plus the probability of 4 plus the probability of 5. And you would add those probabilities. The probability of being less than 2, well, 0 and 1 are less than 2, so you would add those two probabilities. A binomial probability has two outcomes. Independent means that one outcome does not affect the other. N is the number of trials. X is success. How many? P is probability of success. A multiple choice test has 6 questions. Okay, so each question can be right or wrong, and each question has 4 answers. Only one is correct. So N is 6 because there's 6 questions. P is 1 out of 4 because only one question is right out of 4. And 1 divided by 4 is 0.25. The probability of getting all 6 correct, when we find the probability of multiple events, we just multiply each probability. So the probability of question 1 is 0.25. We would multiply that, the probability of getting question 2 right, which is also 0.25. So we're going to multiply 0.25 times itself, 6 of them. Okay, so that's 0.25 raised to the 6th power. Okay, and on your calculator, you may have a y to the x, an x to the y, or this rooftop button. Okay, all of those you would use to do an exponent. Okay, the probability of all 6 being wrong, okay, well, that's 0.75 because there's 3 wrong out of 4 choices, which is 0.75. So we would multiply 0.7 times itself. We're doing 6 because we have 6 questions. The probability of at least 1 wrong, we're going to use this website, stattrek.com/online-calculator/binomial. Okay, it gives you several answers when you do this. So what we input is N equals 6. N is number in the sample, number of questions. X is how many successes, so we're going to put 1 in for X. Probability, we're going to put in 0.75 because it said incorrect. Okay, incorrect. Then hit compute, and the answer you're looking for is the one that says X is greater than or equal to 1. Okay, because it said at least 1. That means 1 or more. Okay, and that will give you your answer. Okay, the probability of at least 1 wrong is the opposite of all correct. So you do 1 minus the probability that they were all correct, which we found in a previous example. Okay, now when you do two things different ways, they should be equal, but they might have a rounding answer. Okay. All right, what about the probability of at least half correct? Well, half of 6 is 3. So you would use StatTrak. Since it said correct, you use p equals 0.25. Okay, and you would put in x equals 3, but the answer you're looking for is x is greater than or equal to 3, because at least means 3 or more. Okay, if you have a binomial with 100 trials and the expected value is 60 and the standard deviation is 4.3, unusual means it's more than 2.5 standard deviations above the mean and less than 2.5 standard deviations below the mean. Okay, so to calculate that, you would do 2.5 times the standard deviation. Okay, 2.5 standard deviations means times. Okay, so you have to do that multiplication first. Okay, so 2.5 more would be, you would take the mean of 60 and add 2.5 times 4.3. So you do 2.5 times 4.3 first, and that equals 10.75. So you add to get the upper and subtract to get the lower. So usual values are between. Okay, unusually large would be more than the biggest one. Unusually small would be less than the smallest one. Okay, and that's the end of chapter 5.